Let's now work a superposition problem, and in particular, why don't we go back to problem number 6 from an old exam, exam number 1 from the summer of 2007. Let's change it around just a little bit, it's not that much, but let's say that we want to find this current, I sub 5, in that defined direction flowing through R sub 5, and we want to do that by using superposition. If we look at this, we can see that we have two independent sources. One of those is a voltage source. The other is actually a current source. We can't zero, when we zero things out, we cannot zero these dependent sources. We have to leave those in. But what we want to do now is look at determining this current I sub 5 by doing two separate problems. One problem will go ahead and zero that particular source and solve for the current I sub 5, and we'll call that I sub 5 due to the amp source or the current source. And then the next step, what we will do is we'll actually zero this one, eliminate the current source, look at what happens with I sub 5, or determine I sub 5 when the voltage source is present, and that will give us I sub 5V for the voltage source. And what we want to do then is find the total current, or the true current through resistor R sub 5 when both sources are active, and we can do that by superposition by looking at summing or adding up the two individual contributions to that current that result from looking at the two different independent sources operating by themselves. Let's then start this problem by finding I sub 5 with the voltage source zeroed or not working. So let's then say let's zero the voltage source, or we are now wanting to find half of, not necessarily numerically half, but we want to find one piece of the two pieces. We want to find now I sub 5A, or the contribution of the current I sub 5 going through resistor R5 when only the current source is present. What we want to do then is zero out the voltage source. Now we have to remind ourselves what it means to zero out a voltage source. In this case, if we want 0 volts across the two terminals associated with that voltage source, what that means is we now want to put a wire or zero that particular source. Let's now redraw that circuit for this configuration and analyze that relative to a zeroed voltage source. What we have then is we still have the same circuit topology or structure. It's just we've now replaced that voltage source with a wire. Here's R1, R sub 4, R sub 2, R sub 3, R sub 5. We need to keep that dependent source there, which is a dependent voltage source. Here's R sub 6. This dependent voltage source is given as 4V1, where V1 is actually the voltage dropped from left to right across R sub 1. What we're wanting to find is I sub 5, but in this case the only piece of I sub 5 that actually is there is due to this 4 amp source. We can do this doing the same approach that we've done already maybe in solving this, and that is, let's identify these three mesh currents and solve for those three. In that case, I sub 5a is going to be I sub 2 minus I sub 3. So if we can find I sub 2 and I sub 3, we will be able to find the first part of our current through that resistor R sub 5 going from top to bottom with just one source active, and in particular the source that's active for this piece is our current source, which is 4 amps. You can also see that that particular current source is actually defining I sub 2. Since this particular current is the same as that current, we now know that I sub 2, one of our three unknowns, has already been determined for us. Let's now look at KVL for the remaining two pieces, or two meshes. One, we're going to write a KVL for mesh number 1, which is this mesh, and then we'll write another KVL around mesh 3. Let's now write KVL for mesh number 1. And that's going to be then R sub 1 times I1 plus R sub 4 I1 plus R sub 2, and that horizontal resistor has two of the mesh currents associated with it. We want the voltage drop to be positive from the right to the left across R sub 2, which says that we want the current going from right to left through R sub 2 to be I sub 1 minus I sub 2. And that is all of the drops around mesh 1. This allows us now, because these resistors are all assumed to have unit magnitude or value, we now have I1 plus I1 plus I1 minus I2 equaling 0. Or we now have I3 I1 equaling I2, but I2 we just found to be 4, and so maybe I should denote this as, only due to the current source being present, I sub 1a is then 4 over 3, or 1 1/3 amps. We don't necessarily need I sub 1, but it was a good exercise to find. Now let's go ahead and find I sub 3. We do need I sub 1 because it's going to actually arise because of the fact that going through KVL for mesh 3, we are going to have as one of those pieces this voltage source 4V1, and V sub 1, by definition of the top left voltage drop across R1, V1 is actually R1 I1. Because R1 is 1, V1 is just going to be I1 when we have that in an equation. Now we can write KVL for mesh 3, and starting in the lower left hand corner we then have R sub 5, I sub 3 minus I sub 2. Again, we want the drop now to be from bottom to top, and I3 is going positive in that direction, I2 is going negative in that direction, or against that direction, and so we have R sub 5 times I3 minus I2 plus 4V1, that's the drop across the dependent voltage source, plus R sub 6 I sub 3 equaling 0. Realizing that V1 is I1 and that the R's are all 1, we have 4 V1, which is I1, minus I2. Now we've taken care of those two pieces, and we have plus R5 plus R sub 6, I sub 3 equaling 0. These two are going to give us a coefficient of 2 for I sub 3. I sub 2 is 4 in this particular case. I1 we just computed earlier, and that was 4/3. Or we now know that 2I sub 3 is equal to, taking the minus 4 to the other side gives us a plus 4. Taking the plus 16 over 3 to the other side gives us a minus 16 over 3. Doing a little bit of the algebra, that we then end up with minus 4/3 being equal to 2I sub 3, or I sub 3, when the current source is the only one present, is then minus 2/3. Now we can find I sub 5 with the current source only. That's I sub 2 minus I sub 3. And I sub 2 was 4. We subtract from that I sub 3a, which is minus 2/3, or we now have 4 2/3 for a value of our current I sub 5 when the current source is present, or we now have 14 over 3 for our current source driven circuit. Let's now do the second piece of the solution, which is when we now engage the voltage source and zero the current source. Or now what we're wanting to do is we want to find I sub 5 with only the voltage source present. Redrawing the circuit, here is our 5-volt voltage source. We have R1, R sub 4, R sub 2. Here's our V1 that's used in the definition of our dependent voltage source, which is over here, of 4V1. We then have R sub 6. We have R sub 5. And we have our current source, but remember we're going to get rid of that particular source. And what does it mean to eliminate a current source? If we want zero current to be flowing, then what we do to eliminate a current source is to actually remove it or open it up. And now what we have is the following circuit. We have a circuit that looks like this that we need to analyze, and we can now define our mesh currents, I1, I2, and I sub 3. In this case, you need to recognize that the current flowing through here, there is none, and that's this current, meaning now, because I2 was equal to our current source, we now see that I sub 2, when the voltage source is present, is actually 0 amps. And essentially what we have now is we have these two independent loops or meshes. They would really be independent, but we have this connection between the two because this voltage drop is actually defining or controlling a voltage that effectively is opposing I sub 3 in this mesh number 3 piece. Let's do now KVL for mesh 1. We'll have minus 5 plus R1I1, and now that I'm there, let's go ahead and just realize that V1 again is R1I1. R1 is 1, so V1 remains I sub 1 when we need it. And then we'll have R4 and R2 to worry about. And remember, I sub 2 is 0. Even though we've sketched it just to keep track of it, we can see that it does not contribute to any of these voltage drops that we're going to be evaluating or computing around these different meshes. So for mesh 1, we have minus 5. We're going into the minus terminal of the voltage source, plus R1I1, that's V sub 1, plus R sub 4I1, plus R sub 2I1, and that now brings us back to where we started, and those need to sum to 0. We can then see that we have 3 terms involving I1, and each of those coefficients are equal to 1, so we now have 3I1. If we add 5 to both sides, that's going to then give us 5 on the other side, and we now have I sub 1 due to the voltage source only being present is 5 over 3. Let's now look at writing KVL for mesh 3. If we start in this lower left-hand corner and go clockwise around that particular mesh, we're going to have R5 times R3 minus I2, but remember I2 is 0, so we really just have R5 times I sub 3 plus 4V1 plus R sub 6 I sub 3. Writing those down, we then have R sub 5 times I sub 3 plus 4V1 plus R sub 6 I sub 3 equaling 0. Remember, V1 was I1. We can now combine the terms associated with I sub 3. I sub 1 was given up above as 5/3, and so we now have the 2 there. 2 I sub 3 is equal to minus 4 times 5/3, or this is now doing a little bit of cancellation. We now have I sub 3 due to the voltage source is now minus 2 times 5/3, or minus 10/3. And we can now say that I sub 5 due to the voltage source is I sub 2 due to the voltage source minus I sub 3 due to the voltage source. I sub 2 again was 0. We subtract a negative current, giving us then 10/3 for I sub 5V. Then, via superposition, we can combine these two separate circuit analysis results and say that I sub 5 is going to be made up of a piece due to the current source being present, another piece due to the voltage source only being present, and we now can put those together. I sub 5A was 14 over 3, I sub 5V was 10 over 3, or we now have 24 over 3, or 8 amps for I sub 5, and if you remember, that was actually the current that was flowing down through I sub 5 in an earlier problem that we solved, but that's as far as we were wanting to push this particular problem, which was to find the current I sub 5 going down through R sub 5 via superposition. And superposition then allowed us to analyze each source separately, each independent source separately, and at the very end add up their contribution to that particular current.